Alright guys, welcome to IngenMinds, and today we're gonna be talking about Newton's second law of motion. This is one topic that a lot of learners actually complain about. Before we actually do anything with Newton's laws, it's always best to familiarize yourself with these laws, okay? Before you actually start working on the calculations and all those things, just first get this principle in mind and understand what it's all about. So Newton's second law states that if a net force acts on an object, the object will accelerate in the direction of the net force, right? Meaning that if you were to push an object, the object will now accelerate towards the direction that you're pushing the object into, okay? This we talked about in the basics when we were talking about forces, whether it's a push or a pull. So what we're talking about here is that when you pull, the box will in turn go towards the direction that you're pulling it towards, because of that's where the force is actually leading, right? So Newton's second law, guys, is actually quite simple and the principle is quite clear. So they go on and say the acceleration produced is directly proportional to the resultant force and inversely proportional to the mass of the object. This means that the acceleration produced depends on the force, but also the mass of the object will affect the acceleration, meaning that the heavier the object, meaning you actually get the principle. Just whenever you think Newton's second law is tough, try imagining it in real life. Whenever you say, okay, the acceleration produced is directly proportional to the resultant force. Think about it. It's a car, right? You are putting in the force, the car will actually accelerate forward, right? But it's inversely proportional to the mass of the object, meaning that if we were to increase the mass of the car, let's just say it was you in the car, right? And then now we add 4 more people. Let me just say we even add people with more weight and we add some things in the back seat and the boot actually, right? So the car will now have more mass. This means that this will affect the acceleration. This is what Newton's second law is actually talking about, right? That the acceleration is directly proportional to what? The net force, but inversely proportional to the mass of the object. Always remember that whenever they're adding the mass, just know it's gonna affect the acceleration. Before we actually deal with anything in Newton's second law, I want us to familiarize ourselves with some systems, okay? So on the systems, I took a liberty of drawing a couple of systems right there. These are types of systems that we usually come across. This is the first one, where 2 objects are sitting on a plane, a horizontal plane. This could be object A and this would be object B, and they are being pulled by a force, right? And we're seeing that they're going. This is one of those systems that you're gonna come across. The first thing you need to identify is what is your weakness. For example, these systems actually label that out because in the first system we have 2 objects on a horizontal plane, object A and object B. So what do we know about object A and object B? We know that we talked about forces in my previous video in the basics, where we said whenever you come across problems in Newton, you should always draw out a force diagram first before, okay? So this object, you'll first note out that, okay, the normal and the gravitational force will actually be equal in this case. I'll just write negative mg, but in bracket, this is the normal force, okay? And then we know that there's gonna be some sort of friction as we are pulling the object. Friction is the force that opposes the motion. So when you're pulling the object to the right hand side, the friction is gonna go towards the left. So because of its opposing the motion. So, and then we'll have another force, which will be the tension. And the tension in this case will be positive because of it's giving the object a motion which is almost like an applied force. So the tension in this case is positive. It's not acting as a drag force, something that's dragging the object and decreasing its speed. And then we're gonna go on to the second object. The second object, guys, as you can see, it will have the same things as the object A, right? But the main change will be it will still have the normal, the gravitational, the applied force in this case, and then the tension will be negative. The tension, because of this object, is pulling the other one, so it's experiencing a negative force. Okay, so we know that there's gonna be a tension, and then there's also gonna be a frictional force based on the surface, right? So this is the type of system that you're dealing with, and you already know that these are the forces that I'll be dealing with throughout the whole equation. And get this, you don't need to be using the gravitational force and the normal force unless the force is affected and starts acting on an angle. Let's just say the force was to start acting on an angle, like the force was going that direction. When the force acts like this, yeah, now it affects the normal force, and you have to actually split it into components. But as so long as you don't see the force acting in an inclined form or has an angular form, you know that the type of system that you're going to be dealing with usually has a force applied, usually has a frictional force, usually has a tension, usually has those forces that cancel out, and I don't think there's any more forces. So you see, this type of systems would be very easy, but I'm going to show you how we're going to be dealing with them. Before you go to the second problem, let's first deal with a problem like this one, the one that's on a horizontal plane. I'm going to be showing you systems one by one, and then at the end of the systems, I'm going to be solving question papers. And if you want to leave a question paper that you found to be tough and you want to see us tackle it online, just leave it in the comments down below. Just leave the question paper code and the institution name that made the question paper. Okay, I'm gonna make we're gonna go for the system. Okay, we have I already wrote it down. I found this example in the Mind the Gap. Actually, this example, I found it to be quite good for explaining two objects on a horizontal plane. So I'm just gonna draw them out. We'll have two objects. We'll have this, two objects on a horizontal plane. I'm just gonna name them box A and box B. You know, see, this is the force applied, this is the tension. I'll just say this is box A, this is box B. Right, and let me just draw another line right there and just simulate the friction. And also, guys, it's important that when you actually come across Newton's system, you first point out the forces, right? So let's go through the statement and actually point out the forces. So they say we have two boxes, A and B, lying on a table connected by a piece of string. The mass of box A is 3 kg and the mass of box B is 2 kg. Assume that the mass of the string is very small, so we can ignore it. Yeah, right. Classical question of physical science that they always bring up. Ignore the string, right? So a 30 Newton pulling force pointing to the right is applied to box B, causing the two boxes to move. So we already know that, okay, box A was on the left and box B was on the right. So they said the force was on box B. Therefore, the boxes will start moving to the right-hand side. So I'm just going to go ahead and say the right-hand side is going to be positive. I'm just going to label that out before we do anything. So the statement continues and says the surface acts with a frictional force of 5.9 Newton on box A and 4.1 Newton on box B. Right. Now let's go forward. So the first thing that they say they need is to calculate the acceleration. So before we go into that acceleration thing, the first thing we do is to actually draw the force diagram. It doesn't matter, right? It doesn't matter whether you're in exam or where. Draw the force diagram so that you know what you have. Okay, so on the force diagram, we're first gonna draw the little center there, and then we're gonna point out the normal force. Okay, we have that. Excuse my lines right there. And then we're gonna have the gravitational force, call it Fg, and then they said friction, so we know that we have frictional force. Okay, and then we also have tension. I'll say tension is pulling towards this direction, it's positive. And then we're gonna go to box B. On box B, we're gonna have the normal, the gravitational force, and then the tension. Okay, wait, the tension right there is actually bad. It should be longer. The tension, and then the frictional force, and then we're also gonna have the applied force right here. Right, and then we have force diagrams. We're just gonna go ahead and draw the free body diagrams. So in the free body diagrams, we know that we're just gonna have the normal, the gravitational force. This is for box A, right? And then we're gonna have the frictional force, and then we're gonna have the tension. And then for box B, I'm just gonna label it A, and then label it B. We're gonna have the normal, the gravitational force, the tension, and also we're gonna include the frictional force, and okay, so the force applied. Right, now I'm gonna talk about why it's important to draw free body diagrams. You see, free body diagrams play an important role in our substitution as we go forward. What am I talking about? Remember that Newton's law says that F net, the sum of all those vector forces, right, is equals to ma. Newton's second law actually goes like that. So F net, what does this mean? It means the sum of all vector forces. The sum of all vector forces. These are the vector forces, guys. These are the vector forces. Point them out, okay? So for box A, I'm just gonna go right there and say for box A, and then say F net is equals to ma, and then we're going to label out those vector forces from our free body diagram. Remember, I said the free body diagram plays an important role in our formula where we substitute. Okay, so what are the vector forces that we have right there? So we know that the normal and the weight are going to cancel out because of they have the same value, right? And then the friction and the tension, however, are this different story. So we're gonna have the tension right there. We're gonna have the tension right there minus the frictional force is equals to ma. And then what was the mass of box A? The mass of box A was 3 kg and box B 2 kg. And let me just point out the frictions. It's 5.9 and 4.1. So we had right there, it's like a G, 5.9. Yeah, and then we're gonna substitute T minus 5,9 is equals to the mass 3, the acceleration that we do not have, and then at the end we're just gonna, let's just make T subject of the formula. The reason why is that remember in mathematics they said you cannot work with two variables, so we're gonna have to eliminate one, and A does not seem like it's gonna go away anytime soon, so we're just gonna say 3a plus 5,9, right? And then for box B it's gonna be the same. F net is equals to ma, and then we're gonna have the force applied, as we know, minus the tension. As I said, it applies the negative force, and then minus the frictional force, is equals to NA. And then the force applied, what was the value? 30 Newton. We're just gonna substitute 30 minus the tension that we do not have, minus 4,1 is equivalent to 2A. So we're still gonna have to make T the subject of the formula. We're gonna minus 4,1 from 30 right there. And then we'll just end up having, let me just write there, for T will be equal to negative 2A plus 30 minus 4,1. Yeah, to simplify it like that. Right. We took the Newton's second law formula and formulated the vector forces for each body so that we can find the acceleration for the entire system. So we have to find the vector forces acting on each object and find out which eliminate what, and find out the final product that, okay, the force applied is this, or the final acceleration is this, and then continue. Okay, so right here we're gonna say since we just created equation 1, which was from box A, and equation 2, which was from box B, we're gonna say let's just say add 1, 2, which simulates a simultaneous equation. Then we're just gonna substitute 3A plus 5,9 equivalent to negative 2A plus 30 minus 4,1. Just gonna group everything on one side, so we're gonna have 5A it's gonna write 5A, and then it's equivalent to 5.9. Okay, when we group everything on one side, it's gonna be 30 minus 4,1 minus 5.9, which is almost like 30 minus 10, which is gonna give us 20, and then and then 5, applying basic algebra here, guys. 5 divided by 5 is 1, so that goes out, and then 5 into 20 goes 4 times, so we'll have 4 meters per second. Right, so that's the acceleration of the entire system. Then we're gonna tune in and we're gonna talk about the second system, where the force acts with an incline. Okay, just before you take off, guys, I would like to say thank you for making it to the end of the video. And if you like the content, please do like, subscribe, and comment down below. And we're gonna be performing experiments going forward in this channel live on YouTube, so that we can show you the ropes of how all these laws are governed. Stay tuned to our content. Catch you next time.